In this section, we're going to look at cholinergic and adrenergic transmission of these neurotransmitters, and then we're going to see how that's done by looking at varicosities, which are going to be a new type of synapse for you. So we'll start with your cholinergic synaptic transmission, and cholinergics are going to be referring to acetylcholine. They both got that choline part of it, and we've said before that they're used by all preganglionic neurons. So all the sympathetic and all the parasympathetic are all sending out acetylcholine, and they're gonna have receptors in there, our nicotinic receptors for acetylcholine. So these are all gonna be exciting the postganglionic neuron. So keep that in mind. And then I say here in the second bullet point, from the parasympathetic system, acetylcholine is released from most parasympathetic postganglionic neurons. Now I've been telling you all along, parasympathetic postganglionic neurons release acetylcholine, and that's true. There are some that are going to release a few others that are neither adrenergic nor cholinergic, and we'll see those in the next set of videos, but that may be things like ATP and nitric oxide, and you'll see that in a little bit. So almost all the time, it's parasympathetic releasing acetylcholine at that second neuron. We'll also see acetylcholine at some sympathetic postganglionic, and those are going to be here, here in the sweat glands of the skin and the vessels going to some of the skeletal muscle that are going to need to open up when we're running from that lion, tiger, or bear so that we can get more blood to that muscle. So that will also be acetylcholine. So these will all be cholinergic type synapses. Adrenergic synapses are going to be used with things that have adrenaline by them. So they've got that same core, adren. So we'll see that in noradrenaline and we'll see that in adrenaline. But again, we use the terms in the States here, norepinephrine and epinephrine. So norepinephrine and epinephrine are adrenergic types of transmissions. And remember, these guys are derived from tyrosine, and they're going to all be catecholamines as far as their chemical makeup, along with dopamine in here. And dopamine can also be used as a neurotransmitter, and you've seen that used primarily up in the brain and the central nervous system. So here we're just seeing norepinephrine being released from a postganglionic neuron, and it's hitting this receptor. We're calling this an alpha receptor, and you're going to see why that is so in a minute. And the alpha receptor is going to accept that norepinephrine. So if you remember that we get epinephrine primarily in the blood from the adrenal medulla, and we get norepinephrine primarily from the sympathetic nerves, and they can share a little bit from each of the other. They're going to either be stimulating or inhibiting, and it's going to depend on the receptors that is receiving them. So we're going to have alpha receptors and we're going to have beta receptors. And some of them are going to be stimulating. So like we learn about the heart increasing heart rate and contractility. We're going to be contracting the muscles of the iris, those radial muscles of the iris. And in some of the smooth muscles of the skin, and many of those blood vessels, they're going to contract because we're going to be pushing the blood away from the skin, which is our primary blood reservoir, and shunting it to the muscles. They can also inhibit, like we talked about in the bronchioles, the smooth muscles in the lungs there, or certain other types of blood vessels where that will allow them to expand to increase the blood flow, like to certain of our muscles. So it's all going to depend on these receptors, and we're going to have multiple types of each of these receptors, and we're going to cover that in the next section. But here, I just wanted to kind of put it all together for you. Again, we can see that we're going to have parasympathetic system releasing primarily acetylcholine at both the pre and post ganglionic neurons. And then we're going to have in the sympathetic nervous system, or the sympathetic system, primarily releasing norepinephrine at this neuron. We can also get a little bit of epinephrine there as well. But most of that epinephrine is going to come as a hormone being released from the adrenal gland. So we see that here. And you can see that with norepinephrine and epinephrine, we're having alpha and beta receptors for those. In this next chart, we're going to see, even though we've got sympathetic nervous system here, a few of them are going to be releasing acetylcholine. So that's going to have a muscarinic receptor. And that's going to be going to the sweat glands and again to some of the vessels, the blood vessels of your skeletal muscle. I don't want you to worry about this one in here. This is going to the renal vessels. We'll talk about that when we get to the renal system. But I thought this was a nice graph just to kind of show you we've got alphas and betas going to norepinephrine and epinephrine, and then we've got muscarinics for those few acetylcholines in the sympathetic system, and we've got muscarinics for acetylcholine in the parasympathetic system. So now we can look at how these neurotransmitters are actually being released. And it's a new kind of method that you probably haven't seen before. If you imagine that we've got the action potential coming down through these axons here, and these axons are going around all of these different smooth muscles, they've got these little bulges in them. And these bulges are what we call varicosities. They're swellings along the axon, and neurotransmitter is released from there. So when you got the action potential coming down here, and it stimulates these cells, it's going to actually increase the voltage, right? So we're going to open up some voltage-gated calcium channels here, and that's going to allow, remember that binds to synaptotagmin, that's going to allow these little vesicles to fuse to the membrane, and then they're going to release their neurotransmitter. Well, that's what's happening here. We call these synapses en passant. That's a French term, I think. Basically, it's a synapse in passing. So as that action potential comes down here, and it carries on through, it's going to allow these neurotransmitters to be released, and they're just passing through all these different smooth muscle cells. So you can have the same muscle cell being innervated by a sympathetic neuron or by a parasympathetic neuron, and they're going to have different effects based on what these receptors are doing here. So if they're opposing, we're going to call them antagonistic effects, because one may cause that muscle cell to contract and the other one may cause it to release, depending on what ions this receptor is going to generate coming in or out of that cell. And we're going to look at some of those effects a little bit more in the next section.